Hey guys, today we're going to finish our lesson on exponential growth and decay by talking about exponential growth. Growth applies to values that appreciate. Appreciate means the values go up, like typically the value of a home goes up over time. That's appreciation. So we've got two formulas again. Y equals a times 1 plus r to the t power, and that's when it increases by a fixed percent. And y equals a times e to the kt power when k is a constant. This is when growth is continuous, so it's happening constantly. Okay, our first problem. The population of a city of 1 million is increasing by a rate of 3% per year. So it's counted every year, and it's growing by 3%, so there's our fixed percent. If the population continues to grow at this rate, after how many years will the population have doubled? Okay, so we've got a population of 1 million. That's what we're starting with. So that's A. A is 1 million. Okay, now how much are we going to be left with? So what is Y? Well, we're doubling the population, so that means Y is going to be 2 million. Okay, and that equals a times 1 to the r plus t. So r is the only variable we have not filled in yet that we can fill in, 3%. So r is 0.03. T is what's unknown. We have to figure out that time. So y equals, so that's 2 million, equals a, 1 million, the starting amount, times 1 plus r, 0.03, to the t power. Okay, so let's divide both sides by 1 million. 2 million divided by 1 million is 2. So that equals 1 plus 0.03, which is 1.03, to the t power. Now I'm going to put that in log form. So I've got log base 1.03 argument 2 equals exponent t. And last I can use the change of base formula. So that's log of the argument divided by log of the base. Okay, so that's log 2 divided by log 1.03. 23.45 years is how long it will take for the population to double if it keeps growing at 3% per year. Bacteria can multiply when each bacterium splits into 2 new cells, thus doubling the number. If we start with 1 bacterium that can double every hour, how many bacteria will we have after 1 day? Bacteria will grow at a constant rate. We're going to use y equals a times e to the kt power. So y is the amount we are left with, and that's what we don't know, how many bacteria. A is the amount we start with. We started with 1 bacterium. E is a number, not a variable. K. Now, if this is doubling, that means it's growing by 100% every hour. So that's 1.00. And T is 1 day. It's growing, it's doubling every hour. So that means after 1 day, we've gone 24 hours. So y equals 1 times e to the 1 times 24 power. We can simplify that to e to the 24th power. So e to the 24th power is I'm going to round it to 2.65. and that was times 10 to the 10th power. Okay, so there it is in scientific notation. Now I'm going to get the standard notation number out of this as well. So that's 2, and then I've got to move 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I need to add a 0 after that. 2, 6, 4, 8, 9, 1, 2, 2, 1, 3, 0. Okay, so that's how many bacteria we will have after 1 day.